So, if you're wondering what metatables are, you probably searched up this website and this page in particular. And the first thing that Roblox tells you is metatables allow tables to become more powerful than before. Wow, that sounds amazing. Let's use metatables. I want you to throw this explanation out the window away from your head as far as possible, because this does not help us. This is garbage. Let me show you. So now I have a main table and this serves as my table. Now I have another table and this serves as my meta table. What? This is getting confusing. Don't worry, we'll worry about that later. So a meta table is just a normal table. Wait, really? It's just then why are we worrying about meta tables when we can just care about this table then? Well, the uses of meta tables will come later in the video, but for now I just want to show you what they can do. So a meta table is basically a table that you can attach to another table. Now what does that mean? Let's say we call this syntax, which is built into Roblox, called setmetatable, and we put the main, and we want to attach a table to this main table, which is going to be our meta table right here, because we already call it that. So now this meta table is going to stick to this table like some sort of, imagine a flea and a cow, and the flea is just constantly pestering the cow. So this is the flea and this is the cow. Okay, what is the use of this? Well, you see, the meta table can have keys equaling to a function or a table, and these are called metamethods. Okay, but what do they do? Funnily enough, we have them right here in the page. If we scroll down a little bit, we will see the metamethods that we can put into the table, and they all do a certain operation. But we don't know them yet, so let's learn. Now you can read their description, and if you are good at English, you can just immediately figure it out. But if you're still panicking, we'll read the description and make you comfortable. So this one is the most important meta method, in my opinion, because this is basically the foundation for what people use metamethods for in the first place, which is this right here. And it says, fires when table index is indexed, and if table index is nil, which means that it will fire when the table index that you're trying to call is nil. You can also set this value to a table, but we'll worry about that later because this might confuse you. So let's just focus on the first sentence. Now what does this mean? Well, let's not worry about that. Let's put this into our script. So let's copy and paste that and go back to Studio. So now within this, we can paste it in there. Oh no, what is going on? You're supposed to write it like this. So as you can see, underscore index is a key of the meta table. So you need to know dictionaries for this one. And basically Roblox will detect that this is a meta method because you put it under underscore there, and it will just say, oh yeah, it's that method, I know that. So it says it fires it. So it must be a function. And would you look at that? That makes more sense. A function with the table and the index as arguments. So we'll just call the table argument t and the index I. And I'm just going to show you something really quick. Print t and I. Now we have set the meta method, and inside the meta table for this main, we can see that underscore index does this function whenever table index is nil. What does that mean? Well, if you know indexing, then this shouldn't be a problem for you. So what I'm gonna do is I'm going to print the main table, which is this table right here with the smaller meta table attached to it. And I'm just gonna say print main.1. Now you're immediately looking at this and be like, hold on, there's no 1 in there. Well, if I did this, yeah, there will be 1. You would just print this value over here, but right now there's none of that. So what will this possibly do? So as we run the game, you see that it printed table and 1. And also this one printed nil because 1 does not exist. Okay, so it traces back to this line, which, hold on, this function was ran. How did we run this function? Well, you see, it's because 1 does not exist, and like it said that in the documentation page, that this function will run if you try to index or basically find something that does not exist. It will pass what you try to index as an argument, and the table main for your, well, convenience purposes. But usually we ignore main. Alright, so you see the function of underscore index and how it is fired, but why on earth would we even need this in the first place? Why can't we just get rid of this and just call 1? Well, this is more used as for dynamic environments where you're not, where your main table is not a fixed table, and maybe another script is calling this, is trying to pass in a table, but their indexes, well, you don't know their indexes yet. So you want to make a dynamic system that automatically catches anything. Now, what we have done right here is we have basically set up a nice framework for a default table. So let's make a default table. So this default table here has the index, cat, and dog, and they all equal their animal sounds, because why not? So what you might want to do is, whenever you're trying to do main, maybe you want a default value of cat in there, but main does not even have the cat value. Of course, this wouldn't be a very likely scenario in your game, but this is how I show off what you can do with metatables. So when you do print main.cat, reasonably it returns nil, and it will call this function because main.cat does not exist in this table right here. So you call this function with t as main and I as cat. But what you can actually do right here is you can return, oh, I have to put default above the meta table, so right here, and you can return default I. So first, you try to index cat, and main says, hold on, we don't have a cat, but we have a meta table that says that whenever we can't find something in this table, we'll call this function right here. And when this function is called, we have t as main and I as whatever you try to find in the table but does not exist, which in this case is cat. And then it will return the value I from the default table. And as you can see, I is cat and default is this table, which does have cat in it, so it will return meow. So now what we expect for this to happen is to print meow. But setting this function over here seems so chunky and weird. It's like I have to add my entire whole lines code here, and it's so annoying. Well, don't worry, cause if you remember, we can go back into the page and see the second sentence. It says, can also be set to a table, in which case that table will be indexed. So what does that mean? Well, let's get rid of this function and set it to a table like it asked. And let's just set it to default, and I will quickly explain why. So what it means by the second sentence is when we find nothing that we are trying to call inside the main, which is cat, but main doesn't have cat, it will search inside this one, this table instead. And so it will search inside default for cat and return that as, well, the cat. But just to change it up, let's do dog. And it should print bark, because now it finds that dog is not inside the main class, but it is inside the default class. And similarly, if we do like lizard, as you can see, main does not have a lizard, but default doesn't have a lizard either. So we'll just get nil. Why would we ever do this though? This seems so useless. Well, let's talk about classes. Now, it's pretty disastrous for me to explain what object-oriented programming is. So I will use this Google search for trying to explain to you what a class is. So a class is something that we use. It's a technique that we use in object-oriented programming, which is, as you have heard probably by now, that this is the more organized form of programming. We'll take that definition at surface value and go with it. So a class is a kind of object. Interesting. And this object, each they have their own methods, variables. So I have written a few comments over here, and I think they best describe what exactly a class is. So a class can be any sort of object, and in this case I've got an animal, but if you really imagine well enough, you can use class for basically anything. You can use class for pencil. There's different types of pencil in the world. You can use class for a bottle. You can even use class for abstract ideas, but maybe you're not that level yet, so let's start with a simple animal. Now it says that a class has its own methods and variables. Now methods, as you know, are basically just functions. Languages like Python or Java call it methods, but we, Lua, Roblox people call it function. But variables is a shared name across any sort of like programming language, so don't worry about that. So as we know, variables are just certain types of like single data. So for example, for this particular animal, let's say we have 30 health, and its position is vector tree.new, and I pass in a certain position. And we can even call it a string, so its name will be Luffy. And here we have our own methods that we wrote ourselves that determine whether this animal can run, walk, attack, and even die. The bad thing about Lua is that it does not have a class syntax. Now what do I mean by that? Well, if you go to Python or any other programming language, they will have a class built-in syntax that allows you to make class. So example, in Python, you would write it like this. We call the class an animal, and this function right here in Python basically just says whenever you do this, which means calling the class like a function, it will run this. And self refers to a independently created object when you create. So basically when you do this, you create self, which is a new self. And this self will have a variable health of 30, position of this, and his name set Luffy. So you have basically an object right here, which has all these properties, and you can call these properties. But every time you call animal like this, these health, position, and name does not change. So how do we get it to have different, well, basically features? So we can even say, we can pass in a health, a position, and a name as arguments. And in these brackets, like a function, you can call in these three arguments. So let's say we can set the starting health of the animal to 25, and we can add in a vector tree.new of 232, and we can even call him Luffy. So now we can just substitute these arguments, and they will change accordingly. So when I do multiple ones like this, I will call it again, but this time this animal is different from this animal, and it's gonna have its own 11 health with a different position, and his name is gonna be Donald. And you can quickly see how this organizes our code, because it allows us to make certain objects, really, pass in our values, our starting values to them, to allow them to become, well, this. and have their own variables set to these data. And we can use them later on. We can call position on this, and this will be 232, and we can call name on this, and it will be Donald. However, this is all imaginary and inside Python. Lua does not have this functionality. So how can we possibly, well, get this in Lua? Now, what we are about to do with the meta methods is we're gonna try to achieve this goal of creating this exact 3 lines of variables, methods, and a class name animal. So since Lua does not have the class syntax, the best we can do is emulate a class, which means just set it up in a way that it works just like a class in Python or in Java. So as you can see from the example Python script just now, we called a class like a function. So let's just make a function. So now we have a function that you can call like so, just like in the example Python script. So we have created an animal, but hold on, we have not created an animal because we don't have the class syntax in Lua, and this is not how it works. We are just running this function, but we can pretend this function is like a class by having it return a animal, basically, a new animal. So wait, how do we get the animal object that we are gonna return to this have these health, position, name, and even methods of itself? Well, there is one thing in Lua that can contain all these different things, and it's a table. So we can just return a table, and this table will pretend to be like an object. But now here's the thing. We can put these indexes into our table here, and it would act just like what we saw in a Python script. So health would be 30, position will be vector3.new 232, and name will equal to Luffy. And now from here, we can, just like in the Python script, call position, name, and health, and it auto-fills for you because Roblox detects it. So we have a class. But what about the methods and functions? Well, interestingly enough, we can also put functions inside this table. So we'll call this function run. Then I copy paste a few more, and we'll call this walk, and this is attack, and this is die. And of course, whatever you put in here has to be relevant to your game and what the object does in your game. So in this case, maybe I want my animal to just simply print run. And maybe here I can print walk. But that's not dynamic. I mean, every time for every single animal, I'm just going to print the exact same thing. No, we want to print the name did this thing. So what we can do is we can just do animal, the table, and then we get the name, so name, and then we can concatenate and do ran. Now, the unfortunate thing here is that we can't know the animal from within the table because, well, the variable hasn't been made yet. It doesn't know that animal exists. So how do we fix this problem? Well, remember from the Python script just now, you can pass in the parameters and allow yourself to create different types of animals with different, well, variables. So you can pass in health, you can pass in the position, you can pass in the name. So here we just simply do its name, and it works because we pass in the name. Now this animal, we're gonna return this table with all these values and its functions. And since, well, we are using this variable only once, we can actually just copy this table and replace this animal and get rid of this section. So now it returns this table exactly as we see it. So now animal basically this text equals to this table right here. But remember, we have to pass in some values. So the health is going to be 30. Position is going to be vector3.new, and let's just switch it up this time. And we have uh, the name. So let's call it Luffy still. Oh, sorry, I forgot some things here. You have to set this to position equals to this, health equals to, well, health, and name equals to name. So now when we run the game, you should see that we have made a 30 health animal with the name Luffy, and the position is exactly what we passed in here. And just to prove that this isn't like a fixed static piece of code, we can do 5 health. So we can change the values however we like it. We can do 12 tree and we'll call it Donald, just like in the Python exception script. As you can see, we have 2 different tables with the same functions and, well, variables, but they have different values for the variable set. As you can see, 30 health, Luffy has 30 health, Donald has 5 health, and they have different positions. But they do share the same functions because you want both Donald and Luffy to be able to do running, walking, attack, and die. Okay, so let's call some of these functions. Let's say that Luffy attacks. And we don't even have to print because we're not returning the function. So we do, when we call this, it should refer to this right here, and we should name Luffy attacked. It will print Luffy attacked. And for this one, we will say Donald, and we will just say he runs. So now it's super organized, and every time you want to make a new animal object, you don't have to repeat this same line of code. You can just refer to this as a function. Okay, so we've achieved our goal right here, right? Everything's fine. We have made a class, and we've emulated the class at least, and then we have made, well, it do stuff. And this is like super cool and stuff. But how does this relate to metatables? Well, metatables comes in useful now because, as you can see, every time we are calling animal like this, we are actually making a new function. These 4 functions are new functions that will take up your memory. So if I just do, now what? 4 functions for each animal. 1, 2, 3, 4, 5. 5 times 4, we have 20 different functions that does the same thing. 20 different functions. That's gonna take up your memory. That's really bad. How do we make sure that each animal share the same exact 4 functions without having to create a new one every time? Well, this is where the default thing that I showed you about metatables came in. So let's define a global table with all the animal methods in it. And we can just copy and paste the animal methods in it. But the name is gonna error, but don't worry about right now. We're gonna fix that in the future. So this table has run, walk, attack, and die in it. Table, so new animal will equals to a table with the health, position, and name set to their respective arguments. And guess what? We're gonna set the meta table of new animal, which is this table right here, to this table, and we'll return the new animal object. Now it should immediately click in your head, hold on, if I call animal.attack, which I'm trying to call in this table, but attack is not in this table, so oh, it makes sense now. It will look to this one for attack, and there it is. But now here's the problem. We don't have the name. Now, how would I get the name in this table when it's all the way down here? But remember, this animal basically stands as this table, so if we somehow pass in the new, this one right here into this argument, and maybe we can transfer the data and the name into this function somehow, then we can have the exact same thing, but this time we only have 4 functions, and every time an animal object is created, we use these 4 functions that are stored basically in the same place in your memory, and everything's gonna be awesome. And also, don't forget that when you're setting the meta table must have the underscore underscore index, and it's gonna look inside itself. Now this is crazy, but let's call animal methods here, make it a table, and do this. When you call attack, it's gonna be like, hey, there's no attack in this table. But so we look in animal, and animal methods, which is the meta table, has this function, and it'll be like, let's call, oh, this table, it's myself. Okay, I will look inside myself for attack, and there it is. So how can we write it so that these functions over here know about the existence of this table over here and call its name property to be put in here? Well, we're gonna have to go on a bit of a tangent. So inside the Explorer, inside the ServerScript service, now ignore these two because that's my other tests, we can make a ModuleScript. And welcome back. It's a table. A module is basically a table. So when you call, this basically just means this table right here. So, okay, I can just pass in the functions inside this table right here. So then in our main script, we don't have to look at this giant piece of mess. Oh yeah, and the underscore underscore index, we can also pass in here. So now we have stored our methods in a completely separate script. So this is more organized. And in the main script, you don't have to look at so much code anymore. And every time you want to look at or change how the classes functions, you just go to this script and change it. And in this script, it will change as well. Okay, so now we can pass in the module as this meta table for the new animal, but how does this help us? I mean, it's in a different script, that's cool, but that didn't really change anything, right? We'll see right now, inside the module script, this is a little bit confusing, so we'll write it like this instead. And there's another better way to write this. Instead of writing equal to this function every time, we can actually just do function module.run. And this is basically the same as, well, this. And I will do the same for the rest. But we still don't have the name and nothing really changed, so creator, why are you wasting our time and telling us to do all this stuff when nothing has changed? Well, as you can see, we call the animal function here, but what we can actually do that is more intuitive is do function module.new. And we can, this basically just means that we have a new animal object and we'll return this exactly like this. And yeah, so we have new animal and basically we can get rid of this function now. So now it's even cleaner. So now we just do module.new and pass in the health 50, vector 3.new, the 20 and 20, and we have the, what was it again? A name, yeah, so Luffy still. So now this basically is just making a new function. And interestingly enough, you might have seen this somewhere. Interesting, huh? It looks so similar. You create a new instance and you pass in an argument that is special. So let's say I create a camera. Interesting. It seems that an instance is basically itself a class. So we basically made our own like instance, but it's for an imaginary object called an animal. Okay, that's cool and all, but I still want it to attack though, like this. Like how do I call it to attack? Well, what you've seen I just did there is use a colon instead of an index. Now, what does that do? So let's put this in a variable. To make it clearer to you. So Luffy stands for this table right here with all the health, position, and name passed in. And we can make Luffy, well, what we hope to do is make Luffy attack. We can make Luffy die. And we can do all the other methods that exist within here. But as you can see within this table again, attack and die does not exist. Oh, actually, that comes later. Spoilers. Attack and die does not exist, and we're trying to call these non-existent values. But as you can see, we have set the meta table of this table to module, so it will look, and module says that when underscore underscore index, and you are trying to find something that is new here, it'll be like, hey, I'm gonna look in here instead because attack does not exist in this table. So I'm gonna look in here. Oh wait, it's module, which is myself. I'm gonna look in myself, okay? And there is attack, walk, run, die, and they are all stored in the same place in memory. So you don't like consume all your memory trying to make a new object every single time and creating 4 new different functions. But how do I get these functions over here to get Luffy's name? Well, we can just pass in the table over here as an argument. If we pass in Luffy here, which is pretty weird, I must say it looks pretty weird, but as you can see, it passes in Luffy, and animal table will now stand for this table that we made with the new function. And then now we can just call animal table dot name, because, well, the name is inside this table right here. It exists, we made it. So now I filled them all in, and we can go back to the script, and we can just call these functions again and again however we like. And look, it even auto fills. But we have to remember to put in the Luffy every time. So look at this. We can now call walk and pass in Luffy, and let's see what happens. Luffy attacked, died 2 times, and walked. And now we can call it to our heart's desire, and this is very useful for organizing our scripts. But let's be honest. Calling Luffy and then calling run and then having to pass Luffy itself in as a argument, that is so annoying and frustrating. Like, it's, why can't I just do this? Why can't I just and then I have to make a new animal and then put it in there? Luckily, you don't have to do that because we have self and colons. So let's get rid of this. And instead of calling attack like this, let's call attack like this. So this is just a shorter way of writing this. These two are the same exact things. But here's the crazy thing, we don't even need to have an argument here. Because what we can do is call this and get rid of this and call self. So now the function inside the ModuleScript attack also has a colon, and we're using self? What? What is self? So I explained self wrongly. Don't worry, I did that out, but this is a re-recording, so excuse me if my voice sounds different. So self is a Roblox built-in syntax that in this context stands for whatever called this index. To put things into better perspective, let me just write. Now it's giving me a red underline because these are basically the same thing, and it's saying that it's a duplicate function. But in this case, I just want to show you, to make it make sense. So writing this is basically the same as writing this. There's no difference. We'll prefer the shorter way with the colon. And self basically just traces back to whatever called this index, right? What indexed this attack? Luffy indexed attack. So self refers to Luffy. And so self.name refers to Luffy's name that we created here. And they call it self for a very good reason. It basically stands for myself. Myself name. Myself position. Heck, I can do myself self.position and it will work. So let's run the game. And as you can see, it printed the position that I set when I first called Luffy, and Luffy attacked. Now I've changed the formatting for each and every function here to the same as attack. So now we can call like this. We can call Luffy die. We can call Luffy walk, and we can run the game, and you can see Luffy attacked, died, and walk. which means I don't even have to I don't have to store this new animal Luffy object in this variable anymore. I can just call this and do attack. Let's make a new animal. We call it Donald again. And we'll have 20 health. And we have 13 and we have 4. And then it will walk this time. And would you look at that? Luffy attacked and Donald walked. So we can create a new animal every time, new animal. So each of these is their own separate. So let's call them a different name. This one is Jerry, and this one is Mickey, and this one is called, Poe. And these are all their own individual animals, which with their own attacks, with their own walks, with their own runs, and it will all print out different things. So this is amazing. So thank you for watching, and I hope you enjoyed the video, and I hope you now understand classes, object-oriented programming, and why we need metatables to do that. See you later. Oh, one last thing before we go. You don't actually have to write it like this. This is so ugly. You can just do... And yeah, you can just write it like this instead, and it looks much neater with no like extra indents, and yeah. See you later.